Random excitation is widely used to simulate real-world vibration because it reflects motion that cannot be precisely predicted and may experience a number of environmental variables. In a random test, the shaker is driven by a wideband random signal. All frequencies within the wideband signal are excited at once. Typical random profiles look like the one here. A test profile is a target that is normally defined in power spectral density units. It is described in the frequency domain. Here are several different examples of random profiles. The vibration excitation is applied to the object under test using a shaker system. It's conducted for a specified amount of time to verify the device's ability to function in its environment. If a flat spectrum drive signal excites a shaker and test article, the resulting acceleration response spectrum will not be flat. The armature resonances and the dynamics of the test article will produce peaks and valleys in the resultant spectrum. The goal of the controller is to compensate these peaks and valleys so that the vibration spectrum meets its target. A good controller will closely match the control signal and profile. Slight deviations are expected since the controller is outputting a non-deterministic signal and at the same time controlling that signal. A random test is based on building a transfer function, otherwise known as a frequency response function or FRF. The controller does this by sending a very small drive signal on the order of a few millivolts to the shaker. The feedback from the sensor is then collected by the input channel. Both time waveforms, the drive and the feedback, are converted into the frequency domain, and the subsequent frequencies are divided by one another. This is referred to as the transfer function, and this function is used to drive the shaker. Input channel dynamic range is a key parameter for achieving superior random control. The dynamic range may be thought of as the ability of the controller to control both a very large signal and a small signal within close proximity of each other. In other words, a steep drop or rise in the profile will be difficult for a controller to manage if the dynamic range is poor, less than 90 dB. The Spider controller series can achieve an input dynamic range of over 150 dB using dual 24-bit A to D converters on every input channel. During the random test, various safety checks are applied. For example, the broadband profile line limits, maximum shaker drive voltage limiting, channel overload or loss detection, RMS limits, and limit channels. When a Spider controller is used, many advanced functions can be enabled, such as kurtosis control, non-acceleration control, notching and limiting, or fatigue damage spectrum. Hundreds of input channels can be applied simultaneously. Both a PC and an iPad can be used to interface with the controller. Crystal Instruments has designed the world's first fourth-generation vibration controller. It is network-based, extremely accurate, and highly reliable for random control.